Hey, how's it going? Today we're going to talk about section 7.7, multiplying polynomials. I think you'll find this section fairly easy. Something we've done in the past. Some of this might be a little bit of review. All of it might be a review for some of you, but we'll see how it goes. So some of it's really easy, like multiplying monomials. This is something we've done in the past where all you have to do when you have a monomial and another monomial and you're multiplying them together is multiply the coefficients. So the 5 and the 4, those make 20. You multiply the x's together, and we know by our exponent property from earlier this chapter that we multiply numbers of the same base with exponents. We just simply add those exponents together. So that would be x to the fifth. And that's it. So let's try another one, another monomial, a little bit bigger. Again, multiply the coefficients, -3 and the 4, make a -12. X squared, x to the 4th, makes x to the 6th. And then y to the 3rd, y to the 5th, makes y to the 8th. And you're done. So multiplying monomials is a very simple process. When you multiply a monomial by a polynomial, this is, again, something that I think you've seen in the past. When you have a monomial and then a longer polynomial, we just have to use our distributive property where this 5 has to get multiplied by each term. So the 5 times x squared would be 5x squared. The 5 times the 2x would be 10x. And then the 5 times the 3 would be 15. So again, I'm just going to use that distributive property and distribute that through. Even when the monomial is a little bit bigger, where you have a few things, 2 and x squared and a y. This term just has to get multiplied by each of the terms in the second coefficient. So the 2x squared y gets multiplied by the 5x. So again, we multiply our coefficients just like we did up there, which would be 10. We add our exponents for the x's. We have x squared. We have a single x here, which makes x to the 3rd. And then we just have that lone y. And then we got to take that whole monomial again and multiply it by that -y. So a positive negative makes a negative. 2 and 1 makes 2. We have an x squared. We have a single y. We have another single y, which means we have y squared. All right. So again, that whole term has to get multiplied by each of those terms in the second term. Let's try one that looks even a little bit bigger. Again, this whole term here has to get multiplied by each term, right? So we multiply this term by the first one. We have a 4 and a 1 makes 4. We have a squared, a to the 3rd makes a to the 5th. B to the 3rd, b to the 4th would be b to the 7th. And now we got to take that whole first term again and multiply by the second term. The 3 and 4 and the 3 makes 12, positive. And then we have a squared makes a to the 4th. B to the 3rd, b to the 2nd makes b to the 5th. All right. So multiplying monomials together or a monomial times any kind of polynomial, fairly simple process. Just make sure you use distributive property. Now when we multiply binomials together, where we have a binomial and then another binomial, the process gets a little bit more involved. We have to use what we call the FOIL method. F stands for first, so we take the first two terms, the 2x and the 3x. We have to multiply those together. So this would be the first two terms. 2x, 3x makes 6x squared. Then we have to do the outside numbers, the two numbers on the outside of each other, the 2x and the 5. Well, that would make 10x, 2x and a 5. Then we have to do the inside numbers together. So the 4 and the 3x, those are the two inside numbers. So that would make 12x. And then we have to do the last numbers together. So the 4 and the 5, those would be the last numbers, which would make a 20. So basically what really has to happen is each term here, the 2x has to get multiplied by both terms. And the 4 has to get multiplied by both terms. Every term in the first polynomial has to get multiplied by every term in the second polynomial. So, oops, I forgot the x on that 12, didn't I? So the only thing left to do is we can combine some like terms here where we have a 10x and a 12x. So that would make 6x squared We have the 10x and the 12x makes 22x's, and then we have that 20 there. All right. And then we'd be done with that one. So let's try a couple more examples. Again, we have a binomial. We multiply the first numbers together. That x and x makes x squared. That x and the negative 5, so now we got to do our outside numbers, would make negative 5x. The 2x and the x, or the 2 and the x, would make a 2x. Those are our inside numbers. And then our last numbers, 2 and a negative 5, makes a negative 10. And then again, we can just combine like terms in the middle there. And we get negative 3x minus 10. Okay. What happens if you see something like x plus 5 quantity squared? Well, the common mistake people make is they just think, well, let's just square the x and square the 5. You cannot do that. You have to think of this as x plus 5 times x plus 5, which means we have to FOIL. The x and the x makes x squared. The x times the 5 makes a 5x. Then we have another 5x with our inside numbers. And then our last numbers makes 25. So our final answer, when we combine like terms here, would be x squared, 10x, and a 25. Okay? Let's try one that looks a little bit more involved here. So we take our first two numbers, 3a squared b, and then we have 1a squared b. We multiply our coefficients to get 3. We have a squared, which makes a to the 4th. We have a b and a b, which makes b squared. Then we take our outside numbers, right? This whole thing gets multiplied by this whole thing back here. 3 and a negative 2 makes a negative 6. We have 2 a's, and now we have 2 b's. And then we have to do this negative b. We have to do our inside numbers. Negative b, positive a squared b would be a negative 1. We'd have a squared, and then we would have a b squared. And then we have to do our last numbers, the negative b and the negative 2b. Two negatives make a positive. 1 and 2 makes a 2. And then we would have b squared. And again, we look for like terms. We're not always going to have like terms. It really depends on what the numbers are up there, but most of the time we will have like terms in the middle there especially. So we have that 3a to the 4th b squared. We have a negative 6. We have a negative 1, which makes negative 7 of those a squared b squareds. And then we just have that 2b squared at the back. Okay? And that's really about it. So let's try a couple more examples here. Let's try one where we have a binomial and a trinomial, where it's getting bigger. Well, the FOIL method isn't necessarily going to work here because we have more than just 2 terms in each one. Basically, what just has to happen is each of these 2 terms, the x and then the 2, each of these has to get distributed through that second term. So that x has to get multiplied by all 3. And then the 2 is going to have to get multiplied by all 3. So we have x times x squared, which is going to be x to the 3rd. We have x times a negative 5x, which is going to be negative 5x squared. We have x times a 4, which is going to be 4x. The 2 times the x squared, when we multiply now the 2 through here, gives me 2x squared. Then the 2 has to get multiplied by the negative 5x, which makes negative 10x. And the 2 and the 4 makes 8. And then again, we look for like terms. So we have x squared, or x to the 3rd, sorry. We have x squared there, which makes, so we have a negative 5 and a positive 2, makes negative 3 of those. We have a 4x, we have a negative 10x, which makes negative 6x. And then we just have that 8 there at the end, okay? So you'll notice when we do these, you can almost predict what's going to happen. We'll go back to these on that first term. Before you combine like terms, if you're multiplying 2 terms and 2 terms, when you FOIL that out, you're going to get 4 terms. 1, 2, 3, 4. Yes, they will combine a lot of times back and get smaller, but on that first step, when you multiply 2 terms and 2 terms, you should have 4 terms. When we did this one, we had 2 terms and then 3 terms. We ended up with 1, 2, 3, 4, 5, 6 terms. You can imagine if you're doing a trinomial, 3 terms and 3 terms, you're going to end up with 9 terms. So that can be a long process. So let's try this one. We have a binomial, we have a trinomial, so 2 terms and 3 terms. When we FOIL this out, we better have 6 terms to then look to combine like terms. So again, we take that 3x and the negative 2x to the third, we get negative 6x to the fourth. We take that 3x times the 5x would be 15x squared. 3x and the negative 6 would be negative 18x. And now we got to take that negative 4 through that second term. Negative 4, negative 2 makes a positive 8x to the third. Negative 4 and a positive 5x makes a negative 20x. And then negative 4 and a negative 6 makes a positive 24. So we have 1, 2, 3, 4, 5, 6 terms, just like we predicted. And now again, we look to just combine like terms, and we also want to put them in order, just to put it in standard form here. So we only have the 1, the negative 6x to the fourth. We only have the 1x to the third, so we put that next. We only have the 1x squared, so we put that next, the 15x squared. We do have 2 single x's, so we combine those. Negative 18, negative 20 makes negative 38x's. And then we just have that 24. So we're not always going to have a whole bunch of like terms to combine together, but sometimes we will, sometimes we won't. It's harder to predict how many you're going to end up with a simplified part, but that first step, when you FOIL, you can always tell how many terms you're going to have. Let's try one more example. What happens if you have something like x minus 2 cubed? Well, remember, you have to think of that as x minus 2, and x minus 2. 3 things multiplied together. So what we're going to do is we're just going to pick 2 of those and multiply these together. Let's just pick one. I'll pick the first one and just leave that alone. And then we're going to multiply just these 2 together. And again, binomial, binomial, we can FOIL. We have to multiply the x and the x, which makes x squared. X and the negative 2 makes a negative 2x. And then we're going to have another negative 2x. Negative 2 makes a positive 4. So binomial, binomial, we have 4 terms. We can make our life a little easier by simplifying that, combine those like terms there in the middle. And now we can then do it a second time. And this really is about the only way you want to do this. So there's no way to jump straight from here all the way down. So we just got to do it in pieces. X times, now we got to take that x all the way through. So we get x to the third. X times the negative 4x would be negative 4x squared. And then the x times the 4 would be 4x. And now we got to take the negative 2 through there. So negative 2 times the x squared would be negative 2x squared. Negative 2, negative 4x would be positive 8x. And then we'd have a negative 8. And then we can just look to, again, combine some like terms down here. We only have the 1x to the third. We do have the 2x squareds there, so we can combine those to negative 6 of those. We do have the 2 single x's there. We can combine those to 12x's. And then we just have that final term, okay? So try a few examples. Let me know how it goes, and I will see you guys later.